In this video, I'm going to show you how to identify the traversal type, why this code snippet is a traversal type, and also what order the nodes will print, and the full trace. So here we see public void traverse tree node T. It checks if if the node is equal to null, if it's empty. And then it prints the value of T, then it traverses the left, and then it traverses the right. If it traverses, first we see it traverses root, then we go left, then we go right. So this is a preorder traversal. An example of a tree would be when you have A, B, C, D, E. Now how would you trace this? Let me fix this, A. So the way we would trace this is you first start at A, which is your root. After that, you go to your left subtree, and then you have to go left again. So you go to D, and then you have to go right. So then you go back up, and then you go to E. Then you go back up here, and then you go to B, and you go to A. Then you go right to C. So that's going to be A, B, D, E, C. Now for our next example, we have this code snippet. So you're going to have public void traverse tree node T. First we check if T is null, then we traverse T.get left, then we print out the value of that left, and then we traverse T.get right. So what this means is we are going from left, and then we print, and then we go right. So in this case, this is going to be an in-order traversal. So what this tree would look like is you have A, B, C, you have a D, E. So now you're going to trace this tree. In order means you go left, and then you go root, and then you go right. So first you're going to start at A. So at A, then you're going to go to the left subtree of A, and then you get to D. And then at D, you print D. And then after this, you print B, because you go back up. And then after this, you go back up to A. After you go to A, oh, we forgot, down here, you go up to B. But you have to, after this, you go down to E. And then after you go from E, you go back up, and then you go to, you've already touched B once, so you don't need to do that again. So then you go up to A, and then after that, you go down to C. So that is your final order. And a condition is that if this tree was a BST, your in order would give a sorted order. Now, let's do our third example. Public void traverse tree node T. So we're looking if T, our node, is null, then we traverse the left, traverse the right, traverse.T.get right, system.outprint T.get value. So then after this, we have to identify the pattern. So we can see that it's going left, then we're going right, and then we're gonna print. So this is gonna be a pre-order traversal. So our tree that this is gonna look like is gonna be A, B, C, and this is gonna be D, E. Post order. Sorry. Post order, oh, this, I meant to write pre-order. I mean post order. So post order is when you have left, right, root, which we have right there. So then to trace this, we first start at the left subtree. So you're going to be at D. So then from D, you're going to go to the right. So then you have E. And then after you go to E, then you go up to C. go to B. And then after you go to B, then you go to C. And then after you go to C, then you go back to the root, which is going to be A. So you have D, E, B, C, A. So in overall, when you have, our first example was preorder. And in preorder, you have before recursion. And then when you have in order, it's going to be between left and right. Now for post order, it's going to be after both recursions. If you print first, it's going to be pre, so you print first. If you print in the middle, it's going to be in order. Just dot those. And then when you print last, it's going to be post order. Print last. In addition, sometimes you might see them use like stack dot push instead of print. Also, they could use instead of print or q dot add. So this is the same idea. Just check the position relative to recursive calls.